Hey everybody, welcome to the first video in our scenario series. As I've said, we're going over different commands from the RTFM, but we're also going to be walking through a mock red team scenario from start to finish, kind of explaining the different steps and how the RTFM commands fit into them. So in this video, we're actually going to be setting up all of our red team attack infrastructure. We're going to be using a tool called Sliver as our command and control tool. We're going to be uploading malware to various machines, which is then going to call us back through the infrastructure we set up, and then we can issue all the different commands. We can control all these victim computers out there. It's definitely going to be exciting. So the first goal of this video is going to be to explain what a red team redirector is. So I have a little diagram we're going to walk through. We're going to talk through how the information flows, why we use red team redirectors, why they're important. Then we're going to talk through the various steps we can take with IP tables to firewall and secure that redirector. Since it's running out there on the internet, we want to make sure it's locked down. Then we're going to set up some tunnels with SSH. That's going to carry our traffic from our redirector back to the Kali attack machine we've been using. And then finally, we're going to set up our remote access tool, Sliver. We're going to configure some implants, and then we're going to run them. And then hopefully, if everything works out successfully, we should get some sessions from victim computers in our scenario. So first things first, let's open our Kali box. I have another awesome drawing set up here that should allow us to get a better handle of what a red team redirector is. As I mentioned, red team operators, we use these redirectors all the time to mask our traffic. Now, to better understand this, I want you to look at the diagram right here. Now, if I was setting up on this victim computer and I was setting up my infrastructure, would I want to set it up to call me back directly, exactly like this on the screen, right? Victim computer, straight back to my Kali box, or would I want to relay all that traffic through a redirector? The answer is, of course, relay it through the redirector. And let me put some lines here just to kind of show the general flow of traffic. So you'll see here the victim computer is going to be calling out to this redirector, being relayed through it back to our Kali machine. Now, I don't have an hour to just break down all the benefits of a red team redirector, but I promise pretty much every red team out there, including the bad guys, are relaying their traffic through other sources. Now, there's a couple things to break down here. I want you to remember that a redirector is kind of like a web server just running out there on the internet. It could be a VPS that's being rented. Let's say there's a really cool homepage up there, a full website, an interactive website, because a lot of bad guys and red team operators will configure these to look extremely legitimate. The URL could even be photography.com or just another URL that they set up to try to blend in. And the reason for this is a lot of the malware and a lot of things we're going to be installing, they simulate a user browsing the internet. So if we can relay all this traffic through a website that actually looks legitimate, which we're calling our redirector, we may avoid suspicion. So let's say there's a network defender on this victim computer. They say, hey, there's some suspicious process running and it's calling out to the internet. Let's go look, right? So they go out to the internet, they browse to wherever the traffic's headed, and they find a legitimate website. They may say, hey, George is just browsing this website again. Everything's fine. Let's just move on. Not only that, but it also masks your source IP address, your home IP address here. If a defender sees malicious activity leaving their computer here, they're not going to see it going directly back to where you're launching all your operations. So just to review, our redirector not only masks our source IP address, but it also features a full website, whatever you want to set up on it. That way, when these computers are browsing the website, all that traffic is going through it. Any potential suspicion, they'll go out there, look at it, see it's a full website, and they may give you the pass. Now, one last thing to mention, a lot of red teams actually have multiple redirectors out there. So they may have 4 or 5 different redirectors, different implants. That way, if a defender comes in, they block one of them, right? They're like, hey, bad traffic, I'm gonna block it. You still have all those other redirectors still fully functioning and ready to rock. So hopefully that was helpful. Let's go ahead and continue on here. I'm gonna minimize that. Let's get our redirector secured and set up. So first things first, we talked about a redirector. Let's go secure it. As we mentioned, it is a web server that's just running out there. Anyone can access it. We want to lock it down so only we have access to it, and then just allow a couple of specific ports. It is worth mentioning Amazon and some of the others sometimes will pre-lock it down to specific IP addresses or SSH keys just to try to get around some of the just Wild West people kind of hacking into everything. So first things first, let's SSH up to our redirector here. We're going to SSH rogue operator 72 100 110. Put in our password. Awesome, we're all set. Whenever you run IP tables, definitely need to make sure you have administrative privileges. So let's go ahead, start our administrative session. Okay, awesome. We're all set up here. We're ready to enter in some of our IP tables commands. I'm gonna enter in 3 commands. I'm gonna enter in a command that only allows SSH to the redirector from my specific Kali machine. So that'll lock it down so only I can actually do the connect. And then the second IP tables command I'm going to set up is just allowing port 80. And then the third one's going to be allowing port 443. And that's because Sliver is going to be connecting back through that redirector over port 443 and port 80. So I want to make sure those are open and functioning. And then lastly, we're going to change our IP tables policy to drop all other traffic. Now, this is the best way to set up firewall rules on a system, is actually to whitelist specific types of traffic and then drop everything else. So let's go ahead, let's dive in and take a look. So pulling up the RTFM here, we need to grab one of these commands to get started. So this one looks like it may have a lot of the flags we want. This is just a great example. You know, sometimes the RTFM doesn't have the exact command, but we tried to make sure we had a lot of the different variables in there so you can cherry pick and create your own unique command to do what you need it to do. So first we're going to go through and modify the command, kind of get it to where we want it. And then I promise I'll walk through the full command front to back and explain what all the little flags are doing. So first things first here, we want to append to the input chain because we're talking about traffic coming into our machine. Our interface, we need to do TAC I because again, traffic coming in, not out. And then we need to enter our interface name here. So I do need to go find my interface. I'll show you all a little trick I do. Sometimes I put a little error in a command like right here. I'll hit enter. And then this command is in my history. Because I started modifying the command, this just makes it really convenient. I can just up arrow, continue modifying after I get this interface. Now, this computer does have two interfaces. You can see it here, the ENS18 and then the ENS19. 19 is listing as down, if you look right here, kind of line break between them, but ENS19 is down. We're gonna go ahead and use ENS18 here. This is the proper one. So I'm gonna up arrow, just like I said. Here's the errored out command. Let me jump back to the beginning here. IP tables, input, and then our TAC I interface. So let me close that out. ENS18, TAC P, TCP, perfect, I'm happy with that. Destination port 22, all traffic going to our redirector against port 22. Yep, D port 22 sounds good. M state, new established, happy with that. TAC J, accept, great. There is one more flag I wanna make sure I include, and that is to whitelist only traffic coming from my Kali machine. So let's go back to the RTFM here. Again, we're gonna cherry pick another flag to help us out here. Perfect, TAC S. The TAC S is source IP traffic. So let me paste it in here, fix this little hyphen, TAC S, and then we need to list our Kali's IP address. So let me backspace this just to kind of set it up, and then let's start a new terminal tab, get my Kali IP address, which is this IP address right here. We'll come up here, paste it in. So let's talk through this command front to back. IP tables, we want to append to all the traffic coming into our computer, input. We want to modify traffic, or we want to match traffic that is coming into the interface ENS18. That's TCP, that has a destination port of 22, and that is new or established. And then we also want to make sure that any matched traffic has the source IP address ending in .56. So 172.30.1.56. And then finally, we want to accept that traffic. So I'm gonna go ahead, enter that rule, should be good. Now with that rule entered, let's do an IP tables TAC NV capital L, and then I'm gonna try to expand out this window a little bit more for us. That makes it a little easier to see. Now I wanna show you this NVL, it's pretty cool. So NVL is actually gonna list out your rules just like normal, right? But it's also gonna give you some verbose information, some of which is this packets column right here. You see packets 43. Now this makes it really easy to debug your IP tables rules. It's actually gonna tell you how many packets match under whatever rule sets that you're putting in. So now I know that without a doubt, this rule set is matching on my current SSH session, and I can further prove that. If I do like an IPA, go back, do a relist on all those packets, you'll see that my packet number went up because traffic is actively being transmitted through and matching that rule. So now if we want, we can actually move forward and change our default policy from accept to drop. Now how IP tables works is it's gonna match any rule sets kind of going down that list, and then the last thing it does is enacts its policy. So it's gonna go through and it's gonna say, does traffic match this? Oh yeah, it's Nick's SSH session, I'm good to go. Or it's gonna say, no, it's not Nick's SSH session, get to the policy, drop, and then it just won't accept that traffic. So let's do our IP tables, TAC P, input, drop. And if everything works according to plan, your SSH session should still be valid. I've definitely been on operations where they did not set up the SSH acceptance rule properly, and the minute they set to default drop, they lose connection, which is a huge pain. They actually have to go up and reboot that server to make sure that it's working again. Because remember, IP tables rules are not persistent. The policies are, but all the individual rules have to be loaded on every single startup. Now, awesome, we have our first rule, and good news for you. All the other rules are very easy. They're just kind of a variation of what we already did. So I'm gonna go ahead, let me do my clear just to clear up the terminal here. Let's up arrow to my SSH rule. And then we're gonna put in some similar rules here. We're just gonna take out the source IP because we don't need to match on it. We're going to say all traffic, regardless of source. And then for state, we're going to do TAC-M TCP just to make sure it's TCP traffic. Destination port, I think I'd mentioned port 80 here, but otherwise rules very similar, a little bit more simple, right? Pretty easy. So I'm going to go ahead and add that one. Let's add a rule for 443. IP tables, NVL. We have our 3 rules here. We have our 22, our 80, and our 443. Our remote access tool will be happy because again, it's calling out through 80 and 443, so we really need to have that set up. So now our IP tables are good to go. Our redirector is secured. You may have a bunch of other rule sets in there in the real world, just pushing other ports, other traffic, blocking things, that sort of thing. So now that our redirector is secured, it is time to set up our tunnel. As I mentioned, we have all of our rule sets, it's secured up there, but there's nothing to relay that traffic through. If you remember from our diagram, the traffic has to hit the redirector and then be tunneled back through to the Kali machine. We did go through a bunch of different SSH tunnel techniques in the SSH tunnel section, so definitely go click over there and check it out if you want to see that. But I'm going to use a simple SSH TAC-R tunnel right now. What this tunnel is going to do is it's going to SSH up to the redirector. It's going to open up port 80, and then it's going to send it through the SSH tunnel to my Kali machine on port 80. And that's going to allow my malware to go call out through the redirector, hit my team server, and then connect back into my Kali box. So I'm going to go ahead, exit out of this SSH session. So now let's get our SSH TAC-R ready. So we're going to do SSH TAC-R. We're going to do 0000, and I'm going to explain this whole command before I run it, so don't worry. Port 80, and then I'm actually going to do root, and again, I'll explain why, 110. Perfect, so let's talk through this. So we have our SSH TAC-R here. We're telling it to listen on all interfaces, kind of simple shorthand, on port 80, and then it's going to go through the SSH tunnel, just like we talked about in our videos, and then it's going to target our local loopback port here, 127.0.0.1 on port 80. So this is going to open a port on a redirector, send it all to our Kali attack, and hopefully our remote access tool, Sliver. And then finally here, the root. Whenever you're opening ports on a computer, some of those lower port ranges actually require administrative privileges to open. I have to use my root account here to make sure that those ports get opened and tunneled successfully. So let's go ahead, let's fire this off. It should prompt me for the password. And then as long as you don't get any errors or things like that, it should be good. However, I do not like trusting my tool sets. I'm gonna go ahead, do a netstat, Pantu, and then we can go through here and see, without a doubt, SSH is forwarding port 80 back through, down through our Kali machine. And you can even see here, SSH is the one that has the port open, just to kind of further confirm that we're set and good to go. Now, I do want to mention there are a million different ways to tunnel traffic from a redirector back to a team server setup. There are awesome blog write-ups, videos, all sorts of cool things. I'll try to link some resources in the description below, so you can go check that out. Nginx, Apache Proxy Pass, Mod Rewrite, all these really, really cool things that allow you to manipulate the traffic. I'm using SSH tunnels because it's quick and easy, and because we already taught it in the previous section, so it's a good candidate. Okay, let's recap here. We have our redirector. We talked about what that is and why we use it. We secured it with some IP tables rules. We made sure that only our Kali box can log into it. And then we set it to also accept port 80 and port 443 traffic. And then thirdly, we set up an SSH tunnel to capture traffic up on the redirector, bring it back through the tunnel, and then replay it to our Kali box, where hopefully our Sliver team server is listening and then can catch that traffic. So now it's exciting. We get to set up our remote access tool. You've heard me talk about Sliver a lot already. So Sliver is the remote access tool we're going to use in this course. There are hundreds of remote access tools. You have to pay for them. Some of them are free and on GitHub. Sliver is actually free, which is awesome. If you want to go set up your own lab and practice with it, feel free. Some remote access tools have really complicated, awesome GUIs where you can click and drag and enumerate. It's really, really nice. Sliver is primarily a command line interface based GUI. They do have a pretty big GUI that they wrote in Electron. It's labeled development only, right? Alpha, do not use this in operations. There are some bugs, but I think we might open it in this series and just kind of take a look at it. I'll show it off to you. I'll also link both the tools in the description. Maybe by the time the series comes out, it'll be a lot further along, more mature. But let's go ahead and get started. Let's set this up. This is where it gets really exciting. So let me CD to the desktop here. Check out our Sliver payloads right there. We do want to make sure we have privileges because we're going to be creating payloads and doing all sorts of other fun things. Now the Sliver server is the main component of Sliver. It's pretty cool. A lot of these tools allow you to collaborate with teams. So you start up one server and then you can start up a bunch of different, think of them as players playing the game with you, right? A bunch of different other clients. They can all connect into the server and then you can kind of control the same implants and work together. So let's go ahead, kick off the server here. Some awesome ASCII art. Gotta love it. Gives you some version information and other things as well, and a little tagline here. All hackers gain indestructible. Pretty awesome. So now there's a few commands we want to run to prep Sliver to start to create the different implants and allow us to catch our malware when we execute it on the target machines. So the first thing we want to do is run HTTP and HTTPS. This is going to make sure that both our listeners are up, waiting for our malware to execute. We're good to go there. I'm also going to run this command multiplayer. Multiplayer allows other individuals running clients to be able to connect into your team server. It's pretty cool. That's how our GUI is going to work. Actually, it connects into it like a multiplayer player. So we'll play with that down the road. But the next step is going to be to create our implant, right? We can create a number of different payload types. We're just going to stick to a raw executable payload type, but this is where things get interesting. And this is where you can take entire classes on gaining initial access to networks. In our scenario, we're going to assume we sent our payload to a target via some type of fish, an email, right? Could be an Office product, Adobe, Reader, or something like that, PDF, a number of different items. But again, we're going to use an executable here. So let's go ahead. Let's create our first Sliver executable. So the first command we're going to type here is generate HTTP. And then we have to feed it our redirector IP address. Again, we don't want it calling us back directly. We want it to call it through the redirector. So let's go ahead, fire that off. It is written in Golang, so it takes a little bit of time to compile here. The file sizes are a bit large, but I did also want to mention a lot of the antivirus in this scenario is actually disabled. You can take entire week-long classes on how to properly bypass antivirus and other things out there. So I want to make sure we disabled it. That way we can learn these foundational items. I can run through the RTFM things, but if you are interested, definitely go out there. There's some really, really awesome classes. That would be a natural next step. I will say it's probably more of an advanced thing, being able to bypass AV. You really got to dig into the Windows internals, but yeah, it is what it is. So let's wait for this to compile. Awesome, it just compiled. It did take a little bit of time. Kind of funny, they add their own random names whenever you don't give it a name. So good to know there. But our first step is going to be to test this executable. You never want to create a malicious payload and just go send it to the target. You always want to test it first because this is computers. You know, we're making them do things they're not technically meant to do by running these different malware implants and other things. So make sure you test it on a machine you control. In our scenario here, we actually have access to a Windows attack machine, and that's what you're seeing right here. We're going to go ahead and run this implant on this Windows attack to make sure that it works successfully. Now, first things first, let's get the implant over on this machine. So let me kind of arrange my windows here so it's a little bit easier to jump between the two of them. So you can see here, I have my Kali attack. I have my Windows attack up here. Let me open up a new tab. Now to transfer this file, this is in the RTFM as well. We're going to start up a simple HTTP server with Python. Just remember, this is an unauthenticated HTTP server, so anyone can pull your files. So in a lab environment like this, awesome, use it. But in real world ops, please do not run this. So I'm gonna do Python 3 tacm http.server. We're gonna give it port 8080, something easy to remember. And now it's listening, it's happy. I'm gonna pull my Kali IP here so I have it when I'm over on my Windows attack. And then on my Windows attack, all I gotta do is browse to it. And boom, browsed successfully. Don't forget to put the little port on the end there. As you remember, I did port 8080. And over here, you'll actually see it populate. Hey, I got some traffic, you know, I'm good to go. So now let's go ahead, let's come over here, we'll save it to the desktop of the Windows attack. Desktop, save. It's downloading now. It may take a little bit of time to download. Perfect, we're good to go. So let's go ahead and open it. Hope it works. I believe Smart Screen has to pop up. Yep, perfect. Let's go back to Sliver and then see if it finds the callback. And boom, we just got our callback. So exciting. You can see right here the executable name, Fast Helm. It's calling me back. It's going to show your loop back just because the tunnel situation we have set up. But we can start to get more info. We can do sessions, to get all the different sessions. You can see right here, the user that's calling back is Rogue Operator. That's the user that's logged into that Windows attack machine. You can see a little bit of system information, the transport protocol that was used, and you can even dive in and get a little bit more information if you do the sessions tac I, and then you put in the little ID that you see right here in this column. So let's go ahead, do the sessions tac I. So now, I mean, we can run a number of different commands. I'm gonna jump into this a lot more in further sections, but let's kind of look and see all the different processes that are currently running. And then you can also do background. That will kick you out of the session, back to your regular Sliver menu. And what do you know, what is this right here? We just got a call back from another machine. Let's do a little triage, see what else we got here. So I just ran my sessions command. Now I have 2 sessions. So Phyllis Snyder here in the Chicago domain, she actually works for Cyber Inc., our fictitious company, and we have a callback on her machine. Now, in the real world, you send out your phishing email with different malicious payloads attached. People may open the email, people may report it, people may delete it, but some of those folks, again, may open it and you may start to get callbacks. So you now have access to Phyllis Snyder. We're kind of pretending she opened that payload and we got our callback. So we're gonna be using Sliver against Phyllis. We're gonna start enumerating her Windows machine, seeing what all's running on it, what she's up to. Does she have programs open, right? We'll be able to learn all that as we walk through the Windows and Linux sections of the RTFM. So make sure to click through that next video. We're gonna start enumerating her machine and seeing what's up.